Hi guys, it's Miss Griffin again. We're taking a look at Unit 5, Skill 9. Your essential question says, how do we construct a midsegment and a medial triangle? Don't worry, we're going to define those words for you in just a second. On the front side, we're going to look at midsegment. On the back side, we're going to look at medial triangle. A midsegment, off to the side, we're going to define it. It connects midpoints of two sides and is parallel to the base. Because we're connecting two midpoints, it must be parallel to the base. So in this first example, we have the steps listed off to the side if you get stuck. It says construct a midsegment such that it's parallel to AB. So I'm going to highlight AB because I know that I want it to be parallel to this. So if I want to make a line that's parallel to AB, well, that line should go in the same direction, parallel meaning never touching. So that means that we need to create triangle DEC such that these two lines are parallel. Well, if I just kind of think about how that's happening, I have to have a midpoint of AC and a midpoint of BC. Midpoints, remember, come from perpendicular bisectors, which you see here in step 1. So we need the perpendicular bisector of AC and BC. Okay, so let's do it. Pick up two different colors. Well, don't literally pick up both right now, just have one in your hand so that you can make the perpendicular bisector of AC. Just like we did in the last video with those dilations of 1/2, this will actually give us something very, very similar. Perpendicular bisector, remember, swing more than halfway, above and below. Switch to C. Swing again. And connect. Remember that our whole goal was to make the midpoint. So we are going to call this D, since we're making triangle DEC. So we have D here, we're going to make E here, and then we'll, of course, keep C. So a different color now, black for me. Center on B. And we're looking at segment BC now, so radius more than halfway. You are allowed to adjust it from your first construction. Don't get caught up in that can't change the radius ever thing, because that's not true. It's just within the construction itself you can't. Okay, so now I have point E right here. And then our goal was to make the midsegment itself, so I'm going to highlight from D to E. Remember, midsegment connects midpoints of two sides and is parallel to the base. So DE is my midsegment. Okay. Now, after doing this construction, we can now conclude quite a few things. Triangle ABC, the huge, gigantic triangle, is something to triangle DEC. Hopefully, because you know that there are parallel bases, you know there are some congruent angles. And if we have all angles congruent but not congruent sides, that means the triangles are similar. DE is called the midsegment. Of the triangle, and therefore DE is half the length of AB. That's a really cool thing, actually. If DE were the length of, I don't know, say 4, then AB would have to be 8. If we knew that AB was 8, then we cut it in half to get 4. Okay, so there's a special relationship there. And last but not least, we now know that DE is parallel to AB. And we had mentioned that midsegments were parallel to their bases up here. Okay, so that's a midsegment. Now we're going to use midsegments to help us make a medial triangle. What? Medial triangle. Okay, so flip it over. The medial triangle, if we define it off to the side, it connects three midsegments. And we'll say that those are formed by midpoints. So we need to dilate triangle SNO by a scale factor of 1/2 to create triangle ABC such that ABC is the medial triangle of SNO. So we need a medial triangle, meaning we need 3 midpoints, which then means that we need 3 perpendicular bisectors to create those midpoints. So we're going to do the perpendicular bisector of SN, of NO, and SO. So grab 3 different colors just like we did in Skill 8. I've got my red, black, and blue pens here ready to go. We're going to start with the perpendicular bisector of SN. So center on S, radius more than halfway, which mine already is, and swing. Switch and swing again. Remember to pause the video or rewind it if you need more time, because maybe I'm going too fast for you. And we're going to make triangle ABC, so I'm just going to kind of go in the order that we're making these points. Okay, now different color. I'm going to do the perpendicular bisector of NO. So same process. You can adjust your radius at this point, but once you swing that first arc for this, you can't change it. And then connect. And this is point B. And now, not only do I have one midsegment, but I need this other midpoint to make the second and third midsegments. So, red pen now. It's getting messy. Center on S. Open up your radius to more than halfway. Don't forget, it's got to go over halfway. And this is C. So now I'm going to connect. There's one midsegment, there's a second midsegment, and here's the third. And I'm going to choose to shade this in again just so I can definitely see it on my paper. So that triangle that we just formed here in the middle is called the medial triangle. There it is. Okay? After doing this construction, we can conclude more things. Points blank, blank, and blank are the midpoints. So that would be A, B, and C. Segments blank, blank, and blank are the midsegments. That would be like AC, BC, and AB. Name 3 pairs of parallel sides. So if I take a look at segment AB, I know that it's parallel to its base, SO. So I'm going to say that AB is parallel to SO, BC is parallel to something, and AC is parallel to something. See if you can fill those blanks in. BC is parallel to SN, and AC right here is parallel to NO. So the last step is to take a look at these pairs of segments that are in a ratio of 1 to 2. So here we can write that as a fraction. I know this seems weird to put big on top, small on bottom, because that doesn't quite match the number. But when we're talking about the ratio, remember it's the dilation, the scale factor from what we had up above. So here we know that we have segments that are in this ratio by looking at a midsegment and its base. So for example, we would say that AB and SO are in that ratio, putting those segment bars on here. And then another pair of segments would be BC and SN. And then last but not least, AC and NO in that ratio of 1 to 2. If you're still struggling with this whole big and small thing, if I were to put the big segment SO, okay, so I totally have you screwed up here. This should be small and big, so sorry. It does make sense with the numbers. I don't know what I was thinking. Alright, so if I put the small segment AB over SO, and I were to cross multiply these, 2 times AB is equal to 1 times SO. And that makes sense. If I take this small segment, multiply it by 2, then I get one of those SOs. Sorry again about the big and the small. We have the small number on top, the big number on the bottom. Whew. Okay, if you have questions, let us know. Again, sorry about the confusion right here. It's just related to the scale factor. And otherwise, work on your practice and you're good to go.